Thank you. Welcome, everybody. I guess too late for that. Right, so I'm Sébastien, as I said, as Ryan said. And today we're going to talk about humans, magic, and AI. I hope it's going to be fun. I think it's going to be very, very fun. I'm a computer vision expert, AI, automation, optimization. That's my stuff. And before I came to my first Flow event in 2020, I had never set foot in a photo studio. So for me, I learned a lot today, and I hope I can bring to you another perspective on how to see images and how to process and make them more beautiful. Also, because I have very different perspective, and what I'll show is probably not something you're used to. If you have questions, even during the presentation, feel free to ask them. I'm really interested in having more of a conversation with you than just me presenting. So just raise your hand, and I'll stop, and you can ask your questions as we go. There'll be also a Q&A session at the end, so don't worry. If you don't want to talk now, you can talk later. All right, so let's get started. And we're going to start with a simple question, you know. Some of you have met me, most of you haven't. Let's say you have a simple task, and you ask me to do it. Would you trust me to do it properly? You know, that's the first question. It depends on the task, Janice is saying, right? So those who would trust me, raise your hand. All right, OK. Nice, thank you. I appreciate the trust. Now, would you trust a bot or an AI to do it? Those who would do that, raise your hand. Quite a few still, right. Now, one of our core values at Pixelz is let data decide. Shall we do that? So here is a historical chart, real historical chart from our own dashboards that shows the customer rejection rate on our masking operation. So we have an AI that does masks that go to the customer. And we have humans who also do masks, who also go to our customers. And then the customer can say, right, I'm sorry, this is not good enough, I'm going to reject it. So these are the rejection rates. There is one curve for the human, one curve for the AI, whichever order, and that's actually the question. Which curve is for the AI and which curve is for the bot? So I'll give you some time to look at that, think about it. Between the screen and me not seeing colors perfectly well, I don't know, that is blue, right, is it? Black, all right. It's supposed to be kind of blue, but all right, let's say black. So who thinks the black is the AI? Raise your hand. All right. So all the others, you think the black is the human, or is it just you don't know? All right, well. The truth is, the bottom one, I guess, what is green? Blue. Blue is the bot, and human is the top one. So basically what that means is customers tend to reject more images coming from humans than from bots. So if you look really at the data, bots are more reliable than humans when they work, which is a big challenge too. But I think that's something really powerful that we learn when we start to really automate, is that humans and AI, they have very different characteristics into what they can do. And in terms of reliability, AI is way better, like maybe consistency, let's say, or way better than humans. Of course, humans can do a lot of things that AI cannot, and that's why they're really great. But they're really different strengths, and that's what we play on at Pixelz. And again, as I said, this is customer rejection rate, right? So what that means is we have the bot or the human, and then it goes through our own internal QA. We have human QAs internally that check the results and then ask for fixing it if needed, before it goes to the customer, which can also check it and reject it. So this rejection rate is after our own QA human approved it. You automate so much of the human doing the mask that at the end, only the QA remains. What do you automate? The QA. So that's one of our most recent challenges is, can we actually have an AI do the work of QA for masking? So the first question you ask is, right, I want to do that. How hard can it be? How hard can it be? So based on the chat we had, we know that the customer rejection rate is about 0.2%, yeah? So 99.8% first-time customer approval rate. So that means that when our AI says a mask is good, it has to be right. It must be right 99.8% of the time. And our internal rejection rate is about 3%, so that gives us an idea of how frequently we're going to reject images. And overall, a bit of statistics and so on, you get up with 99.6% accuracy. So precision and accuracy are different statistics. It's a bit of math, so bear with me for now. We don't need to understand the details of that. Now, that's what we need to do, and let's look at what can be done, you know, and let's be ambitious, you know. What can be done by, let's say, Google. So there is a world-class standard, which is called ImageNet. It's a challenge. It's an AI challenge where you have, I think, 1 million images that you need to classify into 1,000 categories. Google published a paper in 2022, and the performance of their AI, like you imagine the company like Google, performance is 91% accuracy. Our target is 99.6, not 91. So you look at the error rate. Here you have 9% errors, and here you have 0.4. OK. We need to divide the error rate by a factor 20. Now imagine your boss coming to you and say, hey, I appreciate very much your work, but you do 20 times too much waste. Cut that down. That's what we have to do. It's like, whew. Luckily, we have a bunch of smart people. So 99.8% precision is unheard of for any AI. I mean, you go to any AI expert, you say, hey, can you make me an AI with 99.8% precision? They'll say, what, are you crazy? Like, no one does that. But the thing is, somehow, it almost doesn't matter if no one does it or not. It's what we must do. I mean, the quality of the service we deliver, that's what it requires. Lucky for us, that's what we roll out this month. So by the end of the month, or if we're late, maybe next month, we'll have AI doing that in production. Now, there is a big disclaimer here. One slide. So I don't want you coming out of here saying, hey, Pixelz is 20 times better than Google. We are not. We use some tricks. We have, like, as I said, we have some really smart people. We use some tricks, and if the scientific community were measuring the performance with their own standards and KPIs and so on, it wouldn't be as impressive as shown here, right? But we do achieve the performance we need to deliver the quality of service. The 99.8% precision, we do achieve it when we accept images. It's part of the trick. When we reject images, it's not the same. But yeah, so, you know, we achieve that, but don't go saying, hey, Pixelz is 20 times better than Google. We are not. Maybe we're better in some things, but not that much. Now there is an extra challenge, you know, is not everybody needs the same mask for a given image. Some people will say, hey, keep the prop, remove the model. Usually not, though, but still. And so this is defining what we call templates. And so our AI needs to take that into account to say, OK, is it a good mask or not? And we actually do that, too. So what we can do right now is look a bit at some examples of masks that were rejected by the AI. I won't show the accepted mask because they're accepted, so there's no defect, nothing to talk about. But the rejected mask, so we can see here, for instance, that part of the hole between the arm and the body is missing. So that's one, easy. Here you can see very easily the shoe. OK, it's almost straightforward. This is not so straightforward, though. I can give you some time to look at it. And that's actually an issue we have, you know. Part of the way we operate is we really try to be as efficient as possible. We need to be fast, really fast. And when we reject an image, OK, it goes to the photo editor, and then he's got to fix it. But then if you show him this image, he'll say, right, where's the defect? You know, and then he has to look in detail, zoom in everywhere to find the defect. That's not very helpful, is it? If we can tell him, hey, oh, sorry, one too many. If we can tell him, hey, your defect is in that rectangle, That is much faster for the photo editor. And that's what our AI does too. So good performance takes into account the template and even locates the defects roughly, not precisely, roughly, for the human to be able to look into it and see, oh, the laces are not properly done. And then the photo editor can go in and fix it much faster. And in the meantime, so we had basically an AI bot doing the mask, an AI QA checking it, and then if it works, send to the customer, or next step. And if it doesn't work, we send it to a P who can easily locate the defect and then fix it in no time, much less than it would to do the whole mask. So that's that.
Maybe just say PE is
sorry, PE is abbreviation for photo editor, yes. Did you like that magic trick? Second one, color matching. We all love that, right? So color matching is challenging. It's challenging for many different reasons. For humans, we have mostly two challenges. One is color accuracy, both because you need humans with basic things such as good eyesight, not people like me doing that. But also the variability between humans. Color consistency is very important. And you need good hardware and so on. And for automation, the challenge is understanding which parts need recoloring. For instance, if you shoot a blue shirt on blue jeans and the color-to-color match is also blue, OK, right, what am I supposed to color match? Is it the shirt or the pants? So that's why also it's not so easy for the AI to find out. The other thing is, if you want to color match my shirt, you probably don't want to color match the buttons. So you've got to have really, again, super high precision into what you want to color match. Somehow more than what you would do if you needed to do a mask for the shirt, for instance, because if you mask the shirt, you will mask all the little details with it. You don't care. So that's an extra challenge. The way we did it at Pixelz, it's been an evolution. And I think it's good to see, because it's practically the way automation evolves over any time. Initially, we did it manually for everything. In 2020, we started releasing some automation which wasn't based on AI, because the idea was, OK, from our point of view, color and computer vision experts, right, I have a set of colors. I just go looking for the same colors in the image. OK, I have, yeah, more or less. And then I can do the mask properly. And we thought it was reasonably easy, which was not so easy, but not so difficult. The main challenge we had when we did it, and it worked, is that it was way too slow. It would take 1 to 3 minutes to process an image. And you may think, 1 to 3 minutes, what's that? Yeah, the thing is, we do a bit more than 1 image per day. Like Thomas said, 45,000. So then there's the issue of scaling it. And 3 minutes is way too slow for us to scale it. So that's why we said, all right, we need to make it faster. We optimized it, still too slow. So we said, all right, we're going to do it with an AI. AI, we did it this, well, we've been working on it for a year. It's going to be released again, either this month or next month also. Initially, we were not even sure that the AI could match the performance of the non-AI, but we put enough effort into it, and now it works very well. And the advantage of the AI is that it's 10 times faster. So it's not easy to tune and so on, but it's 10 times faster, so we can scale it really to all our production. That will help us tremendously. We also have color matching for the background, not just the product. And color matching the background is way easier. And so for that, we did it like it was easy, 2 to 3 weeks of work. And it works perfectly, so that one is no problem. Now, as I said, we have different challenges. And so I'm going to be very nice and show you how we make humans and AI work together to solve these. As I explained, the first challenge for the AI is to know what it needs to recolor. So we have the input image, and the first thing is we have a human telling the AI, right, this is the product you need to recolor. Recolor the jacket. Then we have an AI that says, all right, from the jacket, I will make a mask. And it makes that mask. It's not perfect, so we have a human to fix it. We're not yet at the level where we can just rely on the AI for that. But as you can see, it's pretty close already. There isn't so much work needed. And then after that, we have a bot to do the actual recoloring. And this is super good because the bot, perfect consistency. You never have to worry about consistency. It's like mathematically always the same. And then we have the QA that will check it. And if it rejects it, then we send it to manual recoloring, and if it's OK, it goes to the next step. So that's how we really leverage humans to fix the defects of the AI, and AI for improving the speed and improving color accuracy and consistency. So really, they work together like that. And these are different, like, it's not on the same machine, really. It's like, this is a human, and he will do just that. And so he has one image, he does that. Next image, he does that, and so on. And that's it. This then goes to servers, separate servers. And then it's a photo editor who will work on Photoshop and do that. And for one image, and then the next image, and so on, just do that. And then here it goes to another server to do that again. And the idea here is, again, that we minimize the lead time so we don't have a human waiting while the AI is processing things. So here we can look at the current output quality. So again, input, output of the AI, output of the human, and output. As we can see, AI is not so bad. Again, so here we have some issues with the hair, but it's reasonably OK. We can see if there are 2 parts to make, it will make the 2 parts. Jacket again. And here we have color consistency, no problem. So that's why we really appreciate the AI for that. And we had some issues sometimes with people telling us in production, we really have issues with color consistency for that customer, and tell them, don't worry, we're going to roll out the automation soon, scale it up, and then you won't have that anymore. So that was my second magic trick. Third one, surprise, glass mannequin. That one was hell, literally hell. Initially, so glass mannequin, you all know what it is, I guess. Probably better than me even. Initially, we said, all right, let's do pants. Pants is easy, you know? And so we did it, and it was indeed very easy. It worked so well that we said, all right, let's do everything. What a mistake. What a mistake. So, because in glass mannequin, you think it's easy, right? And it's always simple. But no, you have so many cases, crazy cases. So you do a T-shirt, all right, easy again. You do a dress, easy again. Now, you need also the back of the dress. Oh, where is the insert exactly, right? Well, the insert is that little hole here. You see the hole here? We put the insert back in. So you've got to handle holes, not just the outside of it, right? And then a shirt. Oh, wait a minute here. Why do we have 3 images for the input? Because we have an insert at the top and one at the bottom. I'm not sure if you can see very well with that screen, but you should be able to. So we do the neck and we do the bottom of the shirt as inserts, right? And underwear. Of course, the front and the back. So you need to do all that. And then it starts to be really tricky, you know? And then you've got bras. And you start crying. And then they go with the back. And then you're like, will you stop? And when you think it's finished, you know, they come in with tops that have only one side and the other side is completely slanted. So you've got to do an insert sideways. And you've got the dress with a slit, you know, and they say, please do that. And they come with things holding in weird ways and so on. And you're like, what do I do? It's completely crazy for automation. And talking about automation, I forgot to tell you something, by the way, also. In addition to all that, all the examples you've seen, our automation did them. All you've seen here. This. Automated. And we're rolling out in production about right now. Maybe a few months, well, maybe next month, but yeah. Yeah. So that was the struggle. And I guess now we're for our Q&A session. So if you have like questions, now is the time. I should, yeah. Will you ever reach 100% automation? So it depends on what you're talking about. We have some skills where we already reach 100% automation, not on the whole production. But for instance, basically, what you need to be aware of is, if you use AI, you will never get 100% automation from the AI. But If you can live with the mistakes from the AI and say, makes mistakes, I don't care, throw them in, then you can reach that 100% automation rate. And so basically, it happens that we have some AIs working on like classification skills and so on to define the quality or simple things like that, or like does it have a mirror or things like that, where we say, right, it's good enough. Remove all the humans, automate 100%. But for things like masking, for instance, I don't expect we'll ever reach it because it's way too challenging, too detailed, and there will always be someone throwing you a curveball. So you don't, yeah. If I need to automate a particular task, what do I need to do that? A lot of things. The first thing is properly define that particular task. And it cannot be a very big task. As Thomas showed you, we have split our work process into many, many small tasks. And that is very, very important. And even when you do, for instance, OK, I just want to automate garment retouch like for shirts. But that doesn't work because for shirt you have color match, you have reduce increase, you have shaping, you have lots of things. And so what you can automate is just one tiny task like, OK, let's do shaping, or let's do remove crease alone. Oh, sorry. Can you fix that? I'll drop this one. So yeah, that is that. All right. Yeah, the metaverse and virtual reality. That's an interesting question. I want to show you something, if that's OK, about the metaverse. So do some of you know René Magritte, a French painter, very famous, and he painted that painting. It's a whole painting, right? And in the painting, he painted "Ceci n'est pas une pipe," which means in French, this is not a pipe. Do you understand why he painted that? He painted that because this is really not a pipe. It is not. Can you take it and smoke with it? No, you cannot, because it is a painting. It is a painting of a pipe, right? Now, this picture, it is not a model wearing a dress. It is a picture of a model wearing a dress, right? It won't walk in front of you, it's a picture. And this, again, is not a picture of a model wearing a shirt. I repeat, this is not a picture of a model wearing a shirt. Why? Because this is not a model. This is what's called a meta-human, a CGI model. Yeah, as realistic as it looks, this is not a real human, and the shirt is not real either. And so I think that's what we need to be aware of in our world, that when the customer goes onto a website, what he sees is not really the product. We all know that, right? He sees an image of the product. He sees a video of the product. But between that image and that video that he sees and the real product that you can see in a shop when you go there, there is a gap. And the question we need to ask ourselves when we talk about the metaverse and CGI is, if I make an image like this or an image like this, is the gap with the real product bigger in one case or the other? Because if the gap with CGI is the same or smaller than with normal photography, maybe it's good enough. It doesn't mean it's the same gap. It doesn't have to be the same gap. Maybe the difference will be, like the kind of differences you'll have will be different, right? But if the perceptual gap from the user's point of view is the same, maybe it's good enough because the gap, again, is not bigger. So I think that's really the take you need to have on CGI, is that, yeah, it's not just about does it look the same. It's about the gap with the real product. When it comes to recoloring, how is the target color introduced to the workflow? So we have many cases, and we kind of handle most of them. You can either put RGB colors, like RGB values, or you put a swatch, or you put an image with a marker on it. That's usually the three cases. And then in all these cases, what we do for the automation is we convert them to RGB colors. We have some ways to do that. So that's how we do that. Will you ever try? What will you never try to automate? I have no idea. What will you never try to automate? Editorial is something very, very challenging. So that's definitely not the first thing we will try to automate. And there are some crazy things that, yeah, I think we'll not try to automate. I can't quote them right now out of my mind. But I think we have a lot of work to do before we start going to things that, oh, this one we cannot automate, and then we're out of business now. No, that we have a lot that we can automate. How much data do you need to train an AI? Big question. At Pixelz, we're super lucky. It's like luxurious. We have our production system, again, with the skills. So for any step we can have the input and output. And because we do 40,000 images a day, it's very easy to get even 100,000 images for training an AI. Now, we started training our first AIs, what, 5, 6 years ago, maybe 7? And at that time, we had about 20,000 images, or maybe even less, 10,000. I mean, the first trials we did with a few hundred. Quickly, we came to 10, 20,000. And with that, you can start getting results. But the performance we have today takes easily 100,000, 200,000 images to get there. So yeah. Yeah. The cost. Yeah. So doing automation, I think the first thing you need to ask yourself is there really a business case at your scale? Because at Pixel scale, and I guess some real big vendors, maybe there is a reason to do that, but it's very costly. Just to let you know, we're investing, what, $250,000 this year into computers to do the training. And finding skills for it is super hard, just finding people with the right skills to do it. So yeah, it's just think a lot about it. And I mean, depending on what you need to do, I think reach out to us and we can advise you. I mean, it's just trying to help, really. And depending on the business case, either we can do it for you or we'll tell you help you how to do it a bit, maybe. I like the first question. Did I ask for a raise? Yes. How much is actually thanks to my AI? A lot, of course. Yes. Well, you know, 70% automation rate, so that gives you an idea. You know, you do the math. I'll let you do the math. I guess it's percentages. That's easy. But yeah, a lot of it is due to the automation we have. And what we need to be aware of is that the automation we have is not just AI and non-AI. For instance, the ghost mannequin is not AI retouch. It's just like non-AI. But there are also like Photoshop scripts that we use to really help the piece be a lot faster. And we run that, and we do pre-processing and post-processing, manipulating things to really maximize the use of the PE time. So it's really a lot of things, not just that. But yeah, it's a lot. So how can creative teams help with the development of AI and automation? Oh, you would like to help us? Oh, thank you. Honestly, I think I don't know enough about what you do to answer that question. And that's why I'm also super interested in real questions and discussions. I think the main issue we often have is clearly defined tasks. So, but I guess we'll handle that internally most of the time. But one of the big challenges you will have when you try to automate something is that people come to you and the requirements they have for automation they're not very clear, basically. They say, oh, I want to do that, and I understand that for you, like you say, oh, I want a feather of 0.7 or something. What does that mean for me, you know? Because for me, I mean, we don't use Photoshop for automation, right? So I'm going to look into mathematical formulas and so on, looking at how many pixels is that, depending on the image scale and so on. So, but that's okay somehow. We do that. And I think for the creative teams, the thing is that some will say 0.7, and that means that to them. And some will say 0.7, and that means something else to them. That's the main challenges we have, really, the human factor. But even in our production, we have the same problem. So I'm not super sure about how. But yeah, I think the human factor is a big thing. Does masking AI works on different color backgrounds or complex ones? Yes, definitely. So we split at some point our images into easier ones and more complex ones. And it turns out the AI works practically the same quality on both. So complexity is not an issue. Background can be an issue sometimes on like really crazy backgrounds, like if you shoot someone with plenty of details and so on. But the thing is, when we do a masking AI, we have what we call a tri-map, which is like a very rough outline. And then we have, so that's the first AI who does that. And then we have a second AI who will do the mask. And basically what will usually happen on crazy backgrounds is that this tri-map will be wrong. And so we have a human who can fix it in like a few seconds. And then we send it back to the AI that does the fine mask, and that one will work no problem. What is actually AI? Yeah, good question. Hype is a real problem, I think. So we have a lot of what you could call scripted automation, although it's not necessarily Photoshop scripts. We have like basically hand-coded algorithms, and we have a lot of it. I'm not sure what kind of separation you would like to have, if anyone wants to make it more precise. Yeah, 50-50, you think? Yeah. Yeah, it's possibly that, 50-50. Again, if whoever asked that question can reach out later for more precision. Can bots be creative? Depends what you call creativity, but yes, they can. I think we have actually reached a stage where they can. Maybe some of you have heard about, what is it, DALL-E 2, and the other one, I forgot the name. Sorry? Yeah, Midjourney. These are really impressive tools. And they reach a super good quality. So there is, some could say yes, but again, you've got to define what is creativity. And that's also a big question when you work in my world, is how do you define actual words, you know? And yeah, you could say yes, you could say no. When talking about color matching, do you mask and QC the mask of the reference photo? No. If I need to automate a particular task, okay, that we did already, what color chart do you use for color matching? So you're talking about, I don't know who asked that question, but is that the little squares, right? We don't. We don't use color charts. Basically, we rely on you for that, though. That is basically where creative people help us. So what happens is we expect, for instance, the reference image to have the right colors in it already. If it doesn't, then there is a problem. You know, I mean, if you give us a reference that's not the real reference, then there is obviously a problem. Same thing when you provide us with RGB values. They've got to be the real RGB values, right? I mean, it doesn't make sense otherwise. So the thing is, the actual color you expect is provided in the reference. If, when you give us a reference, you don't provide the color you want, there is obviously a problem here. Yes. Yes, that's also a possibility. For instance, we could work on, for instance, yes, you provide us a chart, and then we could like try to detect the color match, or even detect like the lookup table for the whole image and things like that. That would be something we could look into. What would be the key things we should look into before starting the automation journey? And I'll get to you. Well, to do automation, you need to look again at well-defined tasks. This is absolutely paramount. Then task where you have easy access to input and output, you know. And then you need to look at the volume, because, you know, I don't know how much that speaks to you, but ROI, you know, return on investment, that's a big factor. So if you put, I don't know, $20,000, $50,000 into developing an AI, then, you know, you need to recoup that investment somehow. So that's that, I think. Yeah, and then can we have the use of products such as Midjourney or DALL-E 2? Right now, I don't really. Yeah, no. Okay, so yes and no. As they are, I don't think we would have a use for them, but they rely on AI technology and AI algorithms that we will, for sure, guaranteed use in our automation. There is something you probably know, it's called in-painting. Maybe you know that. So for instance, when you need to remove an object from the image, so of course you remove the object, like you mask it out, and then you delete it. But then you need to put something in its place, right? And that's called in-painting. And what these algorithms do, they can do in-painting very well. So we're going to use them for that, for instance. That's the kind of things we can do. And I expect that Photoshop will probably start doing that too, at some point. One of the issues with these algorithms is very easy to use online. What you don't see is the huge server running in the cloud. So if you use it on Photoshop, you probably need a rather powerful machine. I suppose you already have, but I don't know how much that can work on the machines you currently have. So yeah. So yeah.
Thank you. Thank you. Everybody give Sébastien
Thank you.
a big round of applause.
Thank you.